clearly because I'm afraid I was disconnected a while ago. All right, this is Aliyah from the Asia eHealth Information Network. Welcome to our second Wednesday's AeHIN Hour. This is our monthly webinar series where we feature topics on eHealth, health information systems, and information technology for civil registration. It's 3:01 here in the Philippines, and we're broadcasting live at the National Telehealth Center at the University of the Philippines, Manila. This webinar is attended by 21 countries in South and Southeast Asia, mostly members of the Asia eHealth Information Network. But if you're not a member yet, it's okay. We'd love that you are joining us to this twice a month webinar that features topics useful for your work as an eHealth professional. Today, we're going to talk on innovation in healthcare IT standards, the path to big data interchange, as there are already a lot of innovation in healthcare happening elsewhere, but we are not yet so sure if adopting standards and ensuring seamless implementation is enough. We're very lucky that we have here this afternoon Rio de Janeiro State University Professor Luciana Cavalini and Healthcare IT Live host Timothy Wayne Cook as they discuss our topic this afternoon. But before we start our session, let me introduce to you our platform, our program, our how to participate, our program details, and our email feedback. We're currently using Cisco WebEx Event Center, and our meeting room number is 861-801-637, and our password is Brazil123. If you are disconnected, please go to bit.ly.com/AeHIN Hour and just type the room number and the password to rejoin our meeting. Your mic will be mute for the rest of the meeting, but you can actively participate by sending your feedback to the session by chatting your response and posting your question. We meaning Mr. Tim Cook and I are monitoring our chat box for your questions and our feedback panel for your additional feedback for the session. You can send your feedback by typing a yes or no, signifying if it's too fast or too slow. You can also send your virtual applause and laughter. So this feature is not maximized in this meeting room, but if you know how to use it, I hope that you could click that and just say a yes if you're hearing the instructions correctly so that I may know if this feature works. Kongorzul Uzilsaikan from NDTC said yes. I hope Mariani from Indonesia, Marco, Mongkol Ako from Thailand could also click a yes. William Lester, thank you for clicking a yes. In our Team Cook, thank you. And for the others, I hope that you will also maximize this feature so that we could participate more effectively in this session. You could also chat your response by typing your message to the speaker or to the panelist, to the host, or both inside the meeting room. And you could also send your chat only to us and not for all the people inside the meeting room. For our program details, this AeHIN Hour will run for a 45-minute talk, and your Q&A should be sent in our Q&A box located in the lower right panel of your screen. And we hope that you will post your question in our Q&A box rather than our chat box. And lastly, please check your emails to answer the email feedback form, which I will be sending right after this session. So those are the things we have to remember: our platform, our ways to participate, program details, and our email feedback. I'd like to introduce to you our esteemed speakers for this afternoon, Professor Luciana Tricai Cavalini. Professor Luciana is a physician with PhD in public health, and she is a professor at the Department of Health Information Technologies, Medical Science College at the Rio de Janeiro State University, Brazil, and a professor at the Department of Epidemiology and Biostatistics, Community Health Institute, Fluminense Federal University, Brazil. Professor Luciana is also the coordinator of the Technology Development Unit in Multi-Level Healthcare Information Modeling and coordinator of the Emergent Group in Research and Innovation on Healthcare Information Technologies. Our panelist, or the moderator of our session, is Mr. Timothy Wayne Cook, who is an advanced electronics technologist with a Master's of Science in Health Informatics degree. He is the creator and core developer of the Multi-Level Healthcare Information Modeling, or MLHIM, specifications and Chief Technology Officer at MedWeb 3.0. He also serves as international collaborator at the National Institute of Science and Technology, Medicine, assisted by the Scientific Computing Brazil. Please welcome our speakers for this afternoon, Professor Luciana Cavalini and Tim Cook. Good afternoon from the Philippines, Professor Cavalini, and good morning from Brazil.
Good morning. It is an honor to be with you sharing this presentation. I want to know if you can see my slideshow.
Not at the moment yet, Professor Cavalini, but I think you should click share your desktop because I just brought back the presenter controls to you.
Okay.
We have 25 attendees at the meeting room, but I hope that we will grow more. I saw already familiar names in our meeting participant list. So we're now seeing your screen, but it's in presenter view. I hope that we could work on a slideshow view because we can see at the moment your notes. So we have presenters from the Philippines, presenter from Medilink, from Health Education Bureau of the Ministry of Health of Indonesia, I believe. We also have our friends from Bangladesh, from Dian Nuswantoro University in Indonesia, from Mahidol University in Thailand, and Dr. Oscar Primadi from the Republic of Indonesia. We also have our friends from the Thailand Health Informatics Standards Development Center, from Nepal, from India, Sunita Chopra, our previous speaker, William Lesser. So I think we're ready, Professor Cavalini. Go ahead and take it away.
Once again, it's a great honor to be here discussing this very exciting topic. Actually, I would like to give a little bit of background why I'm here. Originally, I am a physician and epidemiologist, and it's been almost 15 years that we've been researching and developing innovation in the area of decision support systems to be used at the point of care for disease control and epidemics control and disaster mitigation. And what we started to realize is that this type of application requires a very precise type of information, and this information must have high coverage, and this information can be anywhere. Not all the information will be exactly at that point of care when the case of epidemics is happening or when a disaster happens, because populations are dynamic. And so we started to develop ways of collecting this information in an opportune way. And of course, we soon realized that standards were important. And in 2007, me and Tim, we started to work together, and we tested and we tried to use all the standards that were available, and the technology evolved so much over this period of time, and we realized that some innovation was required, and that's why I'm here. So I was because now we have this hot topic that is big data, and what is big data? This is the first question, right? Because everybody, like the electronic medical records some time ago, would be the solution for all the problems of the healthcare system. And now big data will be the solution for all the problems in the healthcare system. We are not only talking about healthcare IT, we are talking about healthcare system. It's like this panacea that all of a sudden will solve our problems. And so I would like to bring, to start with, some myths and the corresponding facts about big data in the context of healthcare. The first myth is that everybody knows about what big data is. This is something that we'll see that there is no consensus in the scientific literature and in the specialized blogosphere in healthcare IT about the definition of big data. I searched over the definitions that I could find, and actually the various different definitions that I found, they have the 3V in common. And what is the 3V? The first 3 is volume. So big data means existence of a gigantic amount of data. And this data comes in, and then there comes the second V, that is variability. So that means that this data comes in various formats, it comes from different sources, and so, you know, the conventional big data is this coexistence of the structure, non-structure, machine-generated, and other types of data all together and in, as we said, in great volumes. And the other V that is in common in all those definitions is velocity, which means that data is produced and it has to be processed and consumed very fast. In healthcare, there are two V's that are that have a particular concern. The number one is variability, because healthcare information comes from various data sources. Everywhere where the patient is seen, you have data being collected of this patient. And in the current technology that is implemented in the healthcare settings, those data they're locked up in data files, usually, you know, except for some places where some messages can be exchanged between one or two or three systems, but most of the information is locked up in data files. And so what happens is that you have this enormous variability, and it's even more variable than it should be, because you just can't reach the data that is somewhere else. And this is only one part of the variability, because actually, even if the data was completely uniformized, we know that there are different medical schools, like the Western medicine and the traditional Chinese medicine are completely different ways of looking to the same problem. And it's very important to allow different medical schools and different perceptions of healthcare to be registered according to their domain experts. And so that increases even much more the variability. And the conventional systems so far are not capable of dealing with all this variability. And the other is velocity, because you not only have in healthcare, you not only have the velocity of the production of this information, but you have the velocity that this information changes, because the medical technology changes so much and changes so fast that it's very difficult for the conventional systems to keep up with this technological change. The other myth is that big data is new. Actually, just the name apparently is new, because collecting, processing, and analyzing sheer amounts of data it's not a new activity in mankind. The example that I'm giving here is that since the Middle Ages, Catholic monks in Europe, they would develop what we call the concordance, which is they would write books about the correlations of every single word in the Bible. They would choose a certain word and they would look for this word in the whole Bible. So this is a traditional way of trying to deal with a large amounts of data. What is new is that the volume size now is much bigger. And of course, because of the computer speed and that it can be processed and analyzed. The third myth is that bigger data is better. If the amount of information that you have is bigger and bigger, and then the quality of the information that you're gonna have is better. Actually, this is partially fact because in biomedical science, when you're using the quantitative approach to analyze your data, which is what we are usually doing with big data, this is partially fact because the bigger the sample size, we know that increases the precision of your estimates. But the problem is that if you have a large sample size, but your data has a bad quality to start with, there is no biostatistician that can save you. Because if your data was collected with bad quality of the point of care, there is no magic that can be done, and it doesn't matter what's the size of your sample. So actually, in healthcare, for us to be responsible with the analysis that we are doing, thinking about clinical decision support or healthcare policy making, precision and reliability are both equally important. So yes, you need to have bigger sample sizes to have more precise estimates, but those sample sizes need to be produced based on reliable data. And so this is the trade-off that is very difficult to achieve in healthcare currently with the software that we have to collect our data. And the fourth myth is that big data means big marketing. Actually, there is no evidence, even outside healthcare, big data in general, that big data increases the number of customers. Actually, what big data can be useful is when it helps you emerging what we call actionable insights. I mean, an unknown relationship between variables in your data that you can actually implement an intervention based on that. For example, in healthcare, if you can find an unknown relationship between a gene and a disease, that will be something that emerged from your big data. And but of course, when you think about an actionable insight about it, it means, okay, what are we going to do with that now? Gene therapy, counseling, and so you need to think about what your intervention will be. But actually, this whole thing about marketing has little relevance in healthcare, especially in universal healthcare systems, where your customers are, by definition, everybody, which is the situation that we have here in Brazil. Okay, so you want to have big data because it's important for your precision, but how can you get reliable big data? And when we're talking about reliability in healthcare IT, we're talking about getting a data in a format that that represents as much as possible what really happened at the point of care. And this is what all the healthcare IT standards are trying to do. So what I am talking about when I'm saying the traditional healthcare standards, I'm talking about the healthcare standards that everybody knows about, the mainstream healthcare IT standards. The acronyms are very well known by all of us. 827, OPENEHR, and ISO 13606 are the healthcare standards whose primary focus are message exchange among EMRs. And so they are very focused on detailed clinical models and how to model those clinical concepts and exchange them between applications. So this is their primary focus, is how to share information between electronic medical records. This is important for us to remember that all of those standards, 807, OPENEHR, and ISO 13606, they precede in history the emergence of big data in the semantic web. So they couldn't guess that would happen. They couldn't foresee that would happen. So they base their software in technology that precedes this wave of big data in the semantic web. And what's the consequence of that? That those three standards, they have top-down data modeling approach, which means an authority or an institution has to define the clinical models, and all the healthcare settings that decide to use this standard have to accept those data models the way that they were defined by this authority. So what happens is that brings problems for those standards to deal with the 3V of big data, especially the V of variability. Because at the point of care, the domain experts, they're there taking care of the patients. They not necessarily would like to represent the information the way that a certain 807 message, the way that a certain OPENEHR 13606 archetype are mandating them to represent. When you have that, you have information being lost. If the domain expert at the point of care does not agree with the clinical model that he must in those standards to use to represent the information that he's collecting. So this is one part of what we call standards now. The other part of what we call standards now are the control vocabularies. And so it's MAD, LOINC, ICD, and many others. And so they are the ISO 17117 call all of them as control vocabularies. Also, all of those control vocabularies, they precede big data and semantic web in history. And the main focus of all those control vocabularies is pre-coordination of the expressions to define a certain clinical concept, a diagnosis, a therapy, or a lab result, those things. And so once again, is another top-down approach. And so another problem to use those control vocabularies in the world of the big data. In other words, the traditional healthcare IT standards are not prepared to deal with big data. I would like to make a small development about OPENEHR because OPENEHR has a lot of innovation in their fundamentals, so it is important to make a little bit of difference about OPENEHR. Number one is that the current version of the archetype definition language, which is used to build archetypes, is 1.4. And you go there and you read the ADL 1.4 specification, and it makes it clear that it requires an archetype to be what we call the maximum data set for a given concept. What does that mean by the book? I mean, if you want to implement your application exactly according to the OPENEHR specifications, it means that there can be just one archetype for each single concept in the whole globe. So the right thing to do, you need to build your archetype, you need to submit it to the clinical knowledge manager, the CCD-GEN, You need to build a community around this archetype, and it has to go to the archetype life cycle from the draft to all the steps of the life cycle inside the clinical knowledge manager until it's published. And this is the right thing. Needless to say that this is a very slow process. So what are we going to do with the third V of big data, that is velocity? The problem is that there are several archetypes being developed in isolation. Not you go into the by the book procedure that would be going to the CKN and implementing those archetypes there, and because that's the proper governance tool. If you accept that, and you have to accept that an archetype is a maximum data set, because this is how it is defined on the ADL 1.4 specifications. What is promised in the ADL 1.5 specifications that the maximum data model requirement will be removed, but this is not the current specification so far. This is something in the future. This is a promise, just for us to make this difference, because sometimes you go to the forums and this difference is starting to be mixed up, and in my opinion, a little bit confusing. So what happens is that big data is being produced now. We're talking and somebody is producing a lot of data. You know, every single point of care all around the globe, you have healthcare information being produced. So it's being produced now, and it's being produced everywhere. And it is being produced locally. This is important. The vast majority of the clinical information that is relevant to be used in decision support system, that is reliable to be used in policy-making decisions, is developed at the point of care, is developed locally. And this is what we should pursue when we are thinking about building this reliable ecosystem of big data in healthcare. What a big data aware healthcare IT standard is? Number one, it is compliant to semantic web technologies, because this is the ecosystem where big data is supposed to be developed. It is respectful to the different points of view that come from different medical schools. Most of the healthcare IT standards, the conventional healthcare IT standards now, they focus on the Western medicine. They don't have room, they don't have too much room for other expressions of the medical knowledge. It is very important that this big data aware healthcare IT standard is welcoming to all healthcare professionals, not only physicians. So nurses, physiotherapists, pharmaceuticals, all different professions in healthcare should be welcomed by those standards, because actually all those professionals, all those healthcare providers are registering healthcare data. And then needless to say that sometimes from one healthcare profession to the other, the same concept can be modeled differently, because it has to fit the specific workflow of this particular profession. It's important that it is not limited to electronic medical record data modeling. It is important that this big data aware healthcare IT standard looks forward to include eHealth, mobile health technologies, and the Internet of Things. I will talk about it later. And it has to be prepared to deal, as I said, with eHealth and the Internet of Things. So this what
Hello, Professor Cavalini. Could you go back to your slides once more? Um,
we are
uh,
looking for
5
the
minutes
content with it.
back.
Not documentation source and build a file. This information.
Hello?
Excuse me, I didn't understand.
Sorry, Professor Cavalini, you got lost or cut some 5 seconds or 5 to 10 seconds ago. Could you just go back to the first topic that you are discussing a while ago? We lost you by 5 to 6, 5 to 7, 5 to 10 seconds ago.
Okay, so I'm gonna repeat this about the background. Is the typical application design locks up the semantics in the database structure in the application source code. It means that it creates data files. If the information, the data can be exchanged between two applications in this configuration, unless you do very expensive mappings. Different use cases in different scenarios often interpret similar data differently when the semantics are missing. This is another problem that happens with conventional software EMRs. What multi-level modeling does is to provide a way to share the semantics about any medical, actually about any healthcare concept between distributed and independent applications. Which means, when I say distributed independently applications, is that regardless of what software company developed the application, you can share information from one application to the other. So the MLHIM specifications are based on the core modeling concepts that came from OPENEHR. We need to remember that OPENEHR is the original multi-level modeling specification. So this is what OPENEHR and MLHIM are focused, is in to provide semantic external from the application. And so from OPENEHR, MLHIM inherited the multi-level modeling principles. And I'll talk about them later in this presentation. But MLHIM also uses certain conceptual principles from the HL73 because they are very interesting, they are very important, and which is the XML-based implementation. This is very important when we're thinking about big data aware healthcare IT standards that is compliant to the semantic web. What's the MLHIM implementation? So MLHIM simplifies the OPENEHR reference model. The OPENEHR reference model is very guided towards the development of electronic medical records. So there is a lot of residual semantics and a lot of classes in the OPENEHR reference model that are specific to electronic medical records. And MLHIM was developed thinking about the mobile health technologies and the Internet of Things. So this is why the MLHIM reference model is called a minimalistic multi-level model. Only the concepts, the structures that are necessary but sufficient to develop any healthcare concept were kept in the MLHIM reference model. So another thing, leave out of the board and there's a node on ADL and XML. There is lots of information when you move from an object model like the archetype object model and the XML schema. Why? Because the ADL is the proper instance serialization for the. You go back a whole slide. A whole slide. They lost. Okay. So I'll go back to the implementation. So MLHIM simplifies the OPENEHR reference model. It reduces the residual semantics of electronic medical records that is there in OPENEHR. That's why the MLHIM reference model is called a minimalistic multilevel model. MLHIM uses XML instead of ADL. That was a decision to provide tooling and training that are ubiquitous. We need to remember that the whole semantic web is based on XML technologies. And because XML is based on the XML schema data model, there is no loss of information between model semantics and serializations in XML instance. The validation of an XML instance is automatic. And this is a problem when you're serializing the archetype definition language into XML. So let's see the next. Just a note on ADL and XML. There is lots of information when moving between an object model, like the archetype object model, and the XML schema. Why? Because the ADL is the proper instance serialization for the archetype object model. What's happening in the implementation of OPENEHR is, as far as we know, no systems that implement OPENEHR are using the ADL as the instance serialization. In practice, what all the projects that we know about OPENEHR, they are serializing OPENEHR and 3606 data in XML. So semantics is being lost when in this transition. A comparison between the archetype definition language and XML. The OPENEHR test suite includes approximately 1,600 total files with non-independent validations of its files. Actually, doesn't exist. It doesn't exist. Independent validation of those files. The XML schema, on the other hand, the suite contains more than 40,000 independently validated tests. The OPENEHR tools are developed just by one company, and there is only one open source reference model. In XML, there are more than 30 XML editors, open source and proprietary, coming from many companies. And you have another additional tools for the XML family like XSLT, XWary, XLink, and XProt. The open source Java reference model for OPENEHR, and we have studied that, it has not been thoroughly tested and validated so far. And in XML, there are at least 3 widely used XML parser validators, open source and proprietary, from different companies and communities. The only ADL courses that are known are offered by the Ocean Informatics, and there are a few startup courses that are taught by some of them by non-experts. And because it's difficult to become an expert in OPENEHR, you need to learn by yourself because there is no formal education in OPENEHR and ADL. And XML is taught in all computer science courses all over the world, as well as online. thousands of courses. There are 0 books on ABL. Just already have 54 books on XML. And Amazon has almost 12,000 results for books with type XML. Just a small question break, but actually I understand that everybody is asking questions on chat. So I think that in order to be brief, we can move forward.
Professor Cavalini, there are some. Do you want to address the questions later at the end? We have 2 questions from Jonard and Mariani. Or do you want everything to be addressed later?
Well, if they want to ask now.
All right. Jonard from the Philippines said that some of the questions were already addressed, but there's a request here from Mariani Satuwati from Indonesia. Can we have access on your slides? Would it be possible to get access to your slides?
Oh yes, absolutely. I can send them to you, or they can ask me. They can ask me the slides. After sending me an email, I'll have my email at the end of the presentation, and then yeah, sure, those slides are public.
They'll be posted on SlideShare.
Yes.
Right, thank you. Great. Go ahead.
Okay, so let's go ahead. And so now we're gonna talk a little bit about what is the heart of any healthcare IT standardization, that is modeling clinical models, and how we do that in LIM. And so some fundamentals of clinical knowledge modeling. Number 1, we need to accept the fact that we are dealing with a very complex problem. Sharing this 3V big data between distributed, independently developed applications is a very complex task. That's why the healthcare IT standards have 30 years, and that has not been fully accomplished yet. With all those intelligence all over the world dealing with this problem and thinking about the profit that you can have solving this problem, and it's not solved yet, is because it's a very difficult problem. So we need to accept the fact that for every type of difficult problem, there is always a simple solution that is wrong. So simple solutions for the problem of semantic and syntactic interoperability they don't exist. The solution will be as complex as the problem is, but it shouldn't be more complex than the problem. This is one of the issues of the conventional healthcare standards. But the first thing that we need to understand is modeling clinical data with all that variability, with all that velocity of change of the concept. It is a complex task that we need to address if we want to have our big big data used to this. None of the domain of policymaking. When I say responsible, is that you have data that is precise and reliable enough. Even when well-designed clinical data models in conventional software are not interoperable, you still have the problem of having difficulty to analyze all that big data. And so you're not secure to analyze big data that comes from different EMRs that are not interoperable. Why? Because the semantics got locked up in the database. So you have to recover that semantics to understand exactly what that information meant when it was collected at the point of care. Multi-level modeling, on the other hand, is interoperable. But on the other hand, once again, it's a complex solution in clinical model because it requires thoughtful clinical knowledge modeling. If you already tried to model an archetype, you know that it's not a simple task. Okay, it requires dedication. Clinical models in multi-level modeling. And so, just to understand what multi-level modeling is, the information ecosystem in multi-level modeling is structured in at least 2 levels. One is the reference model. The reference model is a generic information model that is shared across the ecosystem. All the applications that are in practices in the model or just a comparison according to your local medical school, to the way that you look at a certain concept. The governance of the archetypes is top-down, is centralized in the clinical knowledge model, is based on consensus, which is something difficult to be achieved in healthcare. Because different medical schools look at concepts differently. And MLHIM is bottom up. So if you publish your CCD and it's a good CCD, it's very likely that another application is going to use your CCD and not model another. But if your CCD is not good, another CCD for the same concept can be modeled. They won't have semantic conflicts because their UIDs are different. But they can be queried across. So it's possible to analyze data coming from 2 different CCDs modeled for the same concept. So the concept definition, the CCDs. In MLHIM, the CCDs are XML schemas that define constraints to the MLHIM reference model in order to model clinical concepts. It's the same idea for any domain model in multi-level model. CCDs can be validated to the corresponding MLHIM reference model by third-party applications. As we said before, there are plenty of tools in XML for you to edit and for you to validate your CCDs and your data instance. The CCD schema, what what is the function of the CCD schema? Is to inform the application developer what is the structure of a valid data instance for each concept that is modeled for that system. So if your CCD is made public, any receptor of a data instance coming from this application can store, can validate, can query that data instance that that is valid according to that CCD. I'm going to show a little bit of the high-level structure of the CCD. So the CCD has an entry inside and it's completed with metadata. We use the Dublin Core Metadata Initiative as the metadata standard. Inside the CCD, you can choose a carrier demographic or an admin entity. So it depends if you are modeling clinical data, demographic data, and administrative data. And the structure of the data is included in a cluster. Cluster is a wrapper of all the structures and data types that you're going to include in your model. And so inside the cluster, you can have another cluster. And this cluster can be divided in other clusters. It depends on how complex you want your structure to be. But the leaf type of the CCD is connected to what we call a DV adapter. So you can have clusters that have many DV adapters, and the DV adapter is just a plug for you to include your data type. And what are the data types for the CCD? You have order data types that are quantified, like DV count for count data, or DV quantity for any type of quantity with units. And you have DV ratio when you want to divide to counts or divide to quantities or divide one quantity by one count, any type of ratio. And you have DV ordered that is very used in clinical models for scores, for instance, and DV temporal for any type of dates and times and durations. And the unordered the type DV string, then you can have DV string with enumeration when you have codes for the categories of a variable. And you can have this DV strings without enumeration where you can write any type of free text. You have DV contour strings, that is a way for you to model the control vocabulary that we discussed before. DV media for any type of multimedia information that you want to persist. And DV parsable for any type of parsable data. Those are the data types. As I told you before, it's a very minimalistic data model, but those data types are sufficient and necessary to model any type of clinical data that you can imagine. And of course, you have DV interval and reference range when you want to define reference ranges for your counts and quantities, or to inform the reference ranges that originated your ordinals. The principles of the milling elements is that the elements of the CCD do not carry any semantics. Why? Since element names are structural identifiers, this is in keeping with the best practice of healthcare knowledge artifact identifiers, as first proposed by James Smith in circa 1988. He says that good identifiers are dumb identifiers. An identifier itself should not have meaning. If an identifier is comprised of other identifiers that have been combined, then the composite identifier is inherently unstable. If the circumstances that related the composite identifiers together in the first place change, the resulting identifier must also change. So this is the problem that you run into when the identifiers of your elements inside the certain clinical model carry semantics. Some technical aspects of the CCDs. They are equivalent to the archetypes in the ISO 3606 and OPENEHR, with the exceptions that they may be defined at any level for any application use. The complex type definitions, they may be reused in multiple CCDs, So you can, if you like to use a certain data type that is good inside the CCD, and you don't like everything about the CCD, you can use this specific data type. The CCDs persist for all time. They are not versions. So if you need to if the technology of a certain clinical model changes, so the concept change, what you do is you build another CCD and you start to use this CCD in your application. But all the data that was collected with the previous version of the CCD will be always validated by the previous CCD, and it will be always possible to be queried about the application that were shared. So you never lose any semantics because you do not migrate databases in LIM. And all the element names are unique identifiers, which allows us to build more than one CCD per concept. The governance model in LIM consists of maintaining. It's very simple. Couldn't be simpler. You don't need to build consensus with anybody. You model the data according to your medical school, and this is more than enough for you to provide semantic interoperability. That does not have any top-down, has nothing to do with semantic interoperability. It's just because the way that the standard, the conventional standard healthcare IT were developed, that was built. Remember, I told you that was all thought before the semantic web. But everything that you need to do to do the governance of your knowledge in LIM is maintaining a copy of the CCDs and the reference models in your application, and made it public if you're going to share that with a third party. That can be done so on the web, or you can do that locally, specify a location, and reference using the very standard XML catalog tools. So because of the naming conventions, the change to the MLHIM reference model does not impact previously defined CCDs or data. So your CCD will be always valid according to the reference model it was built against, and the corresponding XML instance data will be always valid according to the CCD. So if you're gonna build new concepts based on new MLHIM reference model, everything that you need to do is to keep the reference model that you have in your application and the CCDs that you have in your application, and your data will be always valid, and you can query across different CCDs coming from different reference models. That is not a problem for your interoperability. So that maintains accuracy. That is a part of reliability that is very important for big data, forever. What are the resources that are already available for me? The MLHIM reference model. The release version is open source. It's available at www.mlhim.org, and the developed version is available at our GitHub channel. That is www.github.com/mlhim. The CCD generator, the CCD-GEN, it is a CCD editor that is maintained by our laboratory at www.ccdgen.com. And so the CCD generator produces CCDs according to the corresponding MLHIM reference model. And the CCDs that are produced by the CCD-GEN are validated by definition. The application already validates them. Other products that are built by the CCD-GEN are a sample data instance that comes together with the CCD, a JSON serialization of the data instance, a sample HTML form to inform the construction of your user interface, and modules for the R programming language. R is a statistical package to pulling data into our data frames for processing and data analysis. So this is the interface. www.ccdgen.com is where you log in to build your CCDs. Other MLHIM tools are Maple, the MLHIM application platform and learning environment that is a MLHIM repository using an SQL database for persistence with a browser and a REST interface. The MLHIM XML instance converter, so it's an utility to convert MLHIM CCD XML instances to use short URLs and to convert to JSON and back again to XML. So it is intended to demonstrate how mobile apps can use smaller data files to pass over the wire to an API that expects this format and can convert them back to full XML instances for validation. The form to CCD is a web application to build a form and create a CCD from it. It's work in progress. And the constraint definition designer is an open source CCD editor that is work in progress. So in brief, MLHIM is big data ready. MLHIM uses standard XML technologies and embedded RDF to define the syntax and the semantics, which is the technology that is adopted in semantic lab. The semantics are in the CCD and can be easily exchanged or referenced via the web. Their RDF can be queried, can be analyzed and linked using standard tools. MLHIM data can be stored in SQL or NoSQL databases. There are examples on our GitHub channel for AccessDB, that is an XML database, and SQLite3 that can be easily ported to Postgres, MySQL, Oracle. We also have experience with MLHIM data in MarkLogic, that is a NoSQL called clustered environment. In addition to the native XML databases, the small document-oriented nature of MLHIM data is perfect fit for document databases like MongoDB or CouchDB. And MLHIM XML data can be easily be round-trip converted using the Mishik tool for permanent storage and or as an exchange serialization via REST API. Our vision of the future. There are already intuitions inside the healthcare IT world about the inadequacy of conventional EMRs to collect reliable data at the point of care. You go there, you read the blogosphere, and there are people complaining about EMRs being kind of this data silo that this heavy technology that doesn't go anywhere. So we believe that the big data in healthcare will be coming from purpose-specific applications modeled by the domain experts locally at the point of care, because this is what they want to use. They want to use something that is useful for their practice, and not typing information in an EMR that is only important for hospital statistics or to send data to the government. That this is the kind of information that is not reliable. There are thousands of papers about it already. The hardware support for those purpose-specific apps, in our opinion, is mobile computing. So it's eHealth. The other source of big data in healthcare will be coming from the Internet of Things. All those little devices that collect data, vital signs, and heart rate, and blood pressure, and those little watches that people use now connected to their smartphones. This is an enormous amount of data that will be coming inside the healthcare IT ecosystem from the Internet of Things. And what is a fact is that all data coming from eHealth, coming from MLHIM, and even coming from EMRs, which is MLHIM compliant, will participate immediately, automatically, in a semantically interoperable healthcare information system that is completely compliant with the semantic web technology. So that was my presentation. Thank you very much for listening. So those are our channels on Facebook. It's facebook.com/MLHIM2. MLHIM.com is our channel on Google+. @MLHIM2 is our Twitter channel. And MLHIM.org is our YouTube channel where we have instructional material. My my email is lucicav@MLHIM.org, and Tim's email is tim@MLHIM.org.
Hi, okay. We had a couple of privately asked questions about the compatibility with future wearable devices. And the answer is yes. Of course, there is the requirement to build the CCD, the concept constraint definition, that will represent that data. But we're working on that right now, and we'll have some training material about how to do that. And of course, if we have more, as we build more interest in MLHIM, then these manufacturers will be willing to build CCDs and distribute them with the data. Any other questions?
Hello, Tim. I'm sorry. You just addressed the question that I just chat, isn't it?
Yes, that was
okay.
one of the questions that was sent privately from chat.
Okay, and there's another question from our Q&A box. How does MLHIM handle multilingual requirements?
Okay, MLHIM handles multilingual requirements just like any other XML document does, and that is that the language is labeled in the CCD and in the data instances as appropriate. XML has full, internationalization capability. So we didn't have to build any of that technology. All of that is XML and RDF for, defining the RDF triples for the metadata and the semantic links. All that stuff is built for us, so we reuse all of that. There's no point in reinventing another language.
Okay, I think you're not seeing some of the questions which are sent to me from Dr. Mike Newin. How would CCDs work with SNOMED and or LOINC?
You link to control vocabularies through semantic links, and in integrating with the semantic web and big data, use RDF. And let's say in general, you would use like RDF is defined by, and then point to that where that concept is your defining concept in a control vocabulary. And it can be either in a local vocabulary or it could be on, say, BioPortal, where they have permanent links to all of those concepts in SNOMED and ICD and LOINC and .org.
All right, that's the remaining questions that I have in my list. For those who have not yet posted their question, I encourage you to please maximize our Q&A box, and let's take this opportunity to ask our valuable questions to our experts at the moment.
Okay.
Any other questions or comments?
We're finished.
I think. All right. There you go. Please, Tim, please give us a short summary of what has transpired for this afternoon and maybe your call to action or key message.
Well, the key message is, of course, that MLHIM, like any open source growing concept or community, needs participants. We're open to collaboration and input from other people. The things about MLHIM is that the reference model can change across versions and it never has a negative impact on free others. The question about, is there a plan to create a global library much like the CCD-GEN? Think about how things are linked on the internet through the World Wide Web now, and this is the way that MLHIM data is linked to the CCDs, and CCDs are linked to the reference models. The reference models are available on the MLHIM website. And so there doesn't need to be a centralized point for a CCD. A CCD, as long as it exists where the namespace link says it does, it can be what's called dereferenced to that point, then there doesn't need to be a centralized library. And of course, in your applications, you don't want to have that network latency during validation, so you can get a copy of that CCD from wherever its original author posted it, a copy of that CCD, and you use, again, standard technology called a catalog to point to it locally. So it kind of aliases that full CCD ID to the local copy so that you don't have network lag involved in your validation processing.
All right, I think the questions are coming just
those concepts,
now. Go ahead, Tim.
Okay, I see that we have another question. Does it have provisions to record clinical details? Example, the appearance of sputum, backish or blackish, etc. Yes, you would do that through using a controlled vocabulary. That's exactly what they're for. Say like SNOMED is a case use that, and you would link the what we call a pluggable complex pipe, the complex pipe in a CCD. You would add your semantic link to that defining vocabulary and have a way, you may have, this might be a yes or no. And so those would be your two options in a DV string with enumeration. So you just have those two options for the enumeration. And is MLHIM a separate standard from OPENEHR? Yes, it is very much different. And this presentation was all about how it is different. It's based on different languages. The only thing that's similar is the multi-level modeling concepts in order to separate the semantics from the application source code and the database structures. Fuzziness in data, another question is how does it handle fuzziness in data? Fuzziness in data is what we try to get rid of with MLHIM, but of course you're still going to have differences in concepts. But what the place where the fuzziness is handled is not at the point of data initialization, but at the point of data use. So the person using the data will have complete semantics and understanding of what is meant, so they can decide whether that data is fit for their decision-making purpose. And another question is, how will MLHIM change the concept and help moving forward? We hope that MLHIM doesn't change the concept, but realizes the goal of semantic interoperability. MLHIM shouldn't affect the core concept of eHealth. That's affected by many different scientists doing lots of different things. What we want to do is realize the goal that has been the goal since I've been involved in healthcare IT in 1997 of semantic interoperability across applications. Any other questions?
I think we don't have any other questions. We have briefly addressed all the questions which were posted in our Q&A box. And I think that's it. Thank you so much, everyone who attended our meeting this afternoon. The slides are publicly available, and I hope I could just get the link from Team Cook and Professor Cavalini on what they have shown us this afternoon. Yes, Brian, we will be sending the slides. I'm reminding everyone to please check their inbox, as I will be sending an email follow-up regarding the session that we have today, so that you could also get an access on the slides that they have presented. Any other last message, team, before we end our session?
I just want to say thanks to everyone for listening. Look forward to seeing you in the MLHIM community on Google+.
All right, please follow the Google Plus of MLHIM. That's gplus.to/MLHIM.com. See you, everyone, for our next AeHIN Hour, regional AeHIN Hour, which will be on the last Thursday of September, the second Wednesday of September, that is September 10. That our new time slot is 4 p.m. Manila. Thank you. See you on September 10.
Bye. Thank you very much.